Hey everyone, this is Mr. Williams with your video on the math that we're learning today. The majority of 7th graders decided that they wanted to just take today and learn something new, even if it could be from a video, but the counterbalance being that you could work in partners on the assignment. So I'm basically going to teach through this video how I would teach normally. I'm going to run through the notes, do a couple of examples on each page, and then leave the rest to each of you to finish on your, well, not on your own this time, in pairs. So I want to start by just reviewing what we went over yesterday. We looked at a few different types of angle pairs. To start with, we spent the most time on these, crossing two lines. Each set of angles that we would call catty-corner to each other are vertical angles, and those are going to be congruent. So if the angle on the left is 50 degrees, that means the angle on the right, the catty-corner one, is also going to be 50 degrees. If the angle up top is 130, the same applies to the angle on the bottom. Today, we're going to look at the other three types of angles, and we're going to focus on the simplest equation that you could have to write from the other three types of angle pairs. Adjacent angles, just two angles that are next to each other, and then complementary angles that make a right angle, and supplementary angles that make a straight line or a linear pair, or there's a few other names for them. But I'm going to start with adjacent angles. And I will say, I am glad that this happened to fall or that we're learning this particular thing. I would have been happy to teach it in class, but these problems that you were doing today are all going to boil down to just adding or subtracting. So when we deal with adjacent angles, and I'm switching over to blue now, I do need you guys to write what I write here. Essentially, and this is kind of going to be true for complementary and supplementary as well, when we deal with adjacent angles, we're essentially taking the degrees in the small angle and the other small angle, and they equal however many degrees the big angle is. Now, step one, and I believe I would have done this yesterday for vertical angles. The first step is to find the angles, and if you look, you'll see that the angles here are written with letters. I intentionally wanted you to see that because I need you to be able to look at a diagram and pick out, okay, this is angle KLM, angle BLM, whatever. All right, so once you've found your angles, you set up an equation that looks like what you see above. Your small angle plus your small angle equals your big angle. And then step 3, you solve that equation. I am going to, on this side of your assignment, do number 1, number 2. I'm going to skip a bit. I'll do number 6. That'll leave you 5 more to do on this side. So if I look at number 1, it starts by saying find the measure of angle KLM. This angle is the angle that starts at K, moves over to L, and comes up to M. So this is my big angle. The next thing I know is that KLB, this one, is 26 degrees, and BLM, the other small angle here, is 60 degrees. So all that I'm going to have to do here is add my small angle to my other small angle, and that equals my answer. And this is the kind of problem where I can go ahead and just do the calculation. It's a quick bit of addition, 26 plus 60. So that gives me an answer of 86, or 86 degrees. And again, we just got that from taking the smaller angle, KLB, adding it to the other small angle, BLM, which I realize I forgot to underline, but I think y'all could kind of guess where I was going with that. Just adding those together because we had the two smaller angles to get a measurement of 86 degrees for the big angle. All right, so I'll go over number 2 next. To start with, I'm seeing that it says find the measure of angle FGH. So I start at point F, move down to G, over to H. This appears to be my large angle once again. Next, I know that angle FGB, F down to G over to B is 105 degrees. And I know that angle BGH is 54 degrees. This one is going to work just like number one. I have my two smaller angles. All I have to do is add them together. 105 degrees for the first of the smaller angles, plus 54 for the second of the smaller angles, gives me the measurement of my big angle. And then my big angle equals 159 degrees. And you can go ahead and confirm this addition for yourself. Make sure Mr. Williams didn't make a mistake. Now, I would like to say that I'm writing x in each of these just to get you used to thinking of these as equations, even if you already have your variable by itself, as in the case of both of these, because you won't always. And in fact, tomorrow, when I come back, we will go over the much more complicated type of equation that these can lead to. All right, number 6. Find the measure of angle WDC. Start at W, move to D, and then jump over to C. So this now is the angle I need to find. This is going to be my x, and that is going to change this equation up just a little bit. I believe there's one more problem like this, and the rest work like number 1 and number 2. So next, EDC is 145 degrees. This is the entire big angle. And measure of angle EDW is 61 degrees. So this one, as I think you can see just from how I've written this, is going to look a little bit different. Essentially now, I have 61 degrees for one of my small angles. I am adding that to the measurement of my other small angle. And I get the big angle's measurement, which is 145 degrees. So now I will switch over to purple because I'm going to have to solve this like an equation. But the good news is all I have to do is subtract. 61 is being added to my variable. How do I get rid of adding? I subtract. 61 minus 61 will cancel. 145 minus 61 gives me an answer of 84 degrees. And then I left x alone. It's by itself. It's Mr. Williams at a dance. So x is 84 degrees. All right, so those are the 3 examples that I was planning to do on this page. You are welcome to pause this video and try the rest since it's fresh in your mind, or you can go ahead and just try to knock out all the notes immediately. But either way, I'm going to go ahead and jump to the second page now and work with complementary and supplementary angles. So first, we need to remember that complementary means a right angle. I'll go ahead and just use Brown to do a quick diagram here for each of those. A right angle has a little box in it to show that it's a right angle. And then that is not a straight line, Mr. Williams. Your supplementary angles are going to come together to make a straight line. Remember, my little trick for how to remember that, complementing others is the right thing to do. Complementary angles come together to make a right angle. All right, so if you think about the degrees in each type of angle. In complementary angles, the right angle, the one with the box in it, always means 90 degrees. So your 2 smaller angles are going to have to add up to 90 degrees. Supplementary angles add up to 180 degrees. That is a straight line. You can also think of it, and I'm going to switch back to Brown for this diagram, as a right angle here and a right angle over there. 2 right angles make a straight line. 2 90s make 180. And I will remind us, using the 2 blanks, that complementary is a right angle and supplementary is a straight angle. Now the steps for complementary and supplementary angles are actually the exact same as with adjacent angles, except this time we are actually given our big angle. It's either going to be 90 degrees for a right angle or 180 degrees for the straight angle. So step one, we have to find our angles. Step two, we set up an equation that looks like whatever frame we need. Don't mix up that you could go back and forth between right angles, which are 90 degrees, and straight angles, which are 180 degrees. But then your last step is the same as it's always been, you just solve them. So I'm going to do 1, 2, 3, and 4. This will be 2 examples of each type of angle. The other, I believe, 10 problems will be up to you. So for number 1, my little box tells me that we have a right angle happening here. So my equation is going to have equals 90 in it. I'm given one angle as 35 degrees. The other angle I don't know, so I'm going to call it x. The 35 degrees small angle plus the x small angle that I don't know yet equals 90 degrees, the entire right angle. And then I solve this just like an equation. Minus 35, minus 35, 35 minus 35 cancels, and 90 minus 35 gives us an answer of 65. So 65 degrees is the measurement of that angle. All right, then number 2 works very similarly, except we're dealing with a straight angle this time. We know they equal 180 when I put them together, the 2 angles I'm given. I am given 120. I have an angle I don't know, which means I solved this one the same way I solved the other one, except I used 180 instead of 90. I subtract 120, subtract 120. Those cancel, and I don't have a lot of room to write the full form of the x answer. Well, I can do it under. Your answer is 60 degrees. Number 3, another complementary problem, another right angle problem. I'll remind myself that I'm dealing with a right angle, so my smaller angles will have to add up to 90 degrees. I know an angle of 27. I don't know the other angle, so I will call it x. And this just turns into another subtraction equation. Minus 27 on the left, minus 27 on the right. 27 minus 27 will cancel. Come on. So x is 63 degrees, and that is what I can write in that blank. And last one, I wanted to do number 4 because it looks a bit weird. There is a bit of extra information that's meant to confuse you. But if I cross this stuff out, it looks the exact same as number 2, except with a different number. And that's what I want to do for as many of these as I can, just make the whole thing simpler. Let's see. So I have a straight angle. I know my equation is going to have equals 180. I know my 2 angles add up to 180 degrees. I know one of them is 145. I don't know the other one yet, so I'm calling it x. And then since I was adding to my variable, I get rid of that by subtracting. If I see plus 145, I minus 145. Those cancel. And if you already have it, or if you would rather do it on your calculator, that is 35 degrees. So like I said, each of the equations you're going to work with today, each of the pairs of angles that lead you to a little bit of algebra, will just boil down to adding and subtracting. You may work on this in pairs. When you are done, you will have plenty to do, which your sub, whoever they turn out to be, should already have announced. And I will just say one last thing. On the adjacent angle side, keep track of your letters. I didn't have to do a bunch of color coding on the complementary and supplementary side, but I wanted to make sure you could see how you could represent the different angles you were given on the adjacent side, because those are given by their letters, which essentially function like a map.